Hello and welcome back to the Oxford MAT Livestream. My name's James and this is a live stream where we look at mathematics admissions test problems. Good to have you with us. I think there are some people watching live on YouTube and we have chat moderated by a current student as well. Hello to Kay, who reminds me to set an option over there. Good evening to you and good evening to anyone else who's watching. If you're watching live, you can join in with Slido chat, which at the moment is a couple of people. Who have we got? We've got Can and Anonymous and Jacob. And I need to set that to recent as well. There we go, so it's right way up. Chat is also where we run polls. So the polls help me decide what we're doing. And it's also how I can find out how your day has been today. So there's a poll for how is your day today? Which you can vote on a 1 to 5 star scale. There we go. What was the answer? Is Can in chat wants to know about they're taking time off from school to do math questions, which I've never heard of, and they want my opinion on how much is the right amount. I've never heard of anyone doing this, so this is a bit of a tricky question. And then they want to know what score they'll get as a function of, and I have no idea. So sorry, Can, I don't have a fortune ball. Oh, it's John. Right, okay. Sorry, I've misread somebody's username as not being there. Well, never mind. We got there in the end, or we didn't get there, I don't know. 5 stars, somebody's been doing that all of today. There you go, math questions. People are having, what is that? Odd number kind of day. Definitely odd. Extreme emotions, including extremely neutral. That's a thing that's going on here as well. It is the last kind of live stream before MAT 2025, but we do have 2 bonus episodes. So if you're looking for more MAT livestream style stuff, we've got 2. One where we'll talk about MAT 2025. You can watch that one or not, depending on whether you want to talk about the questions afterwards. And then one on interview questions, which is always a lot of fun because I get to talk about interviews instead in the MAT livestream slot. And those are scheduled for, I'm going to say, the future, obviously depending on when you're watching this, either the future, the present, or the past. Those are the options. And there's a schedule on the MAT livestream page. If you really like live streams from Oxford stuff, then we have more in the new year. In January, we will restart the Oxford Online Maths Club, where we'll have more super curricular fun, just other sorts of maths not related to the maths submissions test, unless we feel like doing something related to the maths submissions test. So there we go. Yeah. Also, somebody asked in chat, how was TMUA? Let's find out. Does anybody want to say how TMUA? Anyone say how that went? Nobody. Last week there were lots of people saying we're about to do TMUA, and I'm slightly nervous that what if none of them came back? I mean, maybe I was trying to, maybe they were here for TMUA and now they've done TMUA. So no point being here for the MAT live stream. There's probably some crossover. This is the wrong week to ask, but I wonder if there's anybody who's been joining in just for the TMUA and there's no intention of doing this one. Samuel just says awful, so I'm feeling for Samuel. Someone else says McKay. Jacob says really hard. Okay, it's nice when there's a bit of a consensus, right? Bad. Just says, but just one person just says bad, right? And there's a couple of questions about like difficulty and math syllabus stuff. Let's just do the question about probability. We have one element of probability on the syllabus. It's combinations and binomial probabilities. If you want to find out more about what that means, then earlier this year we did a MAT live stream about that topic. You could either go and watch that video, or you could look at the revision notes that we wrote about that. So if you want to rewind the MAT live stream, all the previous episodes are available on the MAT live stream webpage, which is hopefully nice and easy to find. This button takes us to the live stream right now. I should not click it, otherwise we get the feedback loop. Further down though, you can find these revision sheets. Now, can I remember what this is? Is it a sort of algebra? Yes, it is. Okay, so combinations of binomial probabilities. If you go in there, you can find some examples of me explaining what that means. The word probabilities down here, and then some revision questions. I think actually my revision questions for this may be slightly too hard. So you can have a look at those if you've got some examples of probability. Short answer, yes. Long answer, all of that. Right, good evening. I've learned how to pronounce things in Turkish. Somebody's got a bad cold, or sorry. Right, okay. In the long questions, could we use concepts which are not in the syllabus and yet still get full marks? If you follow the instructions in the question. The questions have been written so that you won't have to do that. The questions have sometimes been written so that you're not allowed to do that. But if you follow the instructions of the question and you do true maths, then you that's allowed. He says, more than allowed, that's doing true maths is considered good. Something you should be aware of course, is if you've correctly identified that this thing is like some named theorem, then just saying, I know the name of this theorem is not a proof, right? If it says prove this thing and you go, oh yeah, this is called the thingy's theorem, right? That's not a proof, that's just you remembering the name, right? So be careful. Or perhaps this is your chance to remember the proof as well, or work out the proof on the spot like everyone else. Okay, good. Do we submit the long form? You type on computer. The person who's asked this question, where are they? You're anonymous. Okay, you're anonymous, so I can't point you there directly. But if you go to the Maths Admissions Test website, the one with the coffee cup, I really hope people have found this page. This has got information about the Maths Admissions Test. It's kind of got the standard information that you might want. Type responses is in there, that sort of thing. There's even a practice test, so you can have a go at that if you like, using a kind of simulator of what's in the test centre. I hope this isn't a problem for people who did TMO before. You can have a look at what that might look like. Okay, I've got to review all the screen. Right, good, okay. I've opened it in a really tiny window. Off we go then. Yeah, there's questions, right? Buttons, great. And you can skip down to, if you like, you can skip over to the longer questions where there's some text on the left. There's a stupidly tiny window. There's some text on the left and a bit of question on the right, and you can type in the box. Yes, please. Great. That's what that looks like. Anonymous says that they watched the video of the first Oxford first year's first maths lecture. I didn't know we'd put that out. I thought maybe we hadn't put that out. There was a video of the very start of the first year's first maths first lecture. I don't think we released the full thing because, anyway, never mind. Well, maybe that's what you mean you've seen. I got just the intro. There you go. I stood up at the start. That was. There. Rosie says, when the timer runs out, will the interface auto submit? I think yes. It definitely doesn't throw away your responses. I think it has to auto submit, doesn't it? Yes. That's the only thing that would make sense. Yes. If you time out, then whatever you've answered so far. If you're in the middle of typing a word, it doesn't let you finish typing that word. It'll just say time out. It's a bit like in a test where they ask you to put down your pens, except in this one they can just take it away, right? There's a question about whether you would do the harder questions first in chat, which people might be interested in. You want to get there. Yeah. I quite liked the social media video they made of the intro to the very first Oxford maths lecture of the year, which happened to have me on the stage. Hooray! They put some music over the top. It made it very emotional. Do you ever sit the mat for fun? That would be tricky for me to do. And Hugo wants to know, am I a tutor at New College? Yeah, I'm a tutor at New College at the moment. Anyway, right. Okay. Thanks for the streams. That's all right. We've been doing them for a few years now. I think this is. I've got to count on my fingers. This is my 6th time of doing the last mat stream before the actual mat. Probably for you it's the first time round. For me this is the 6th time of being here, of doing this last stream. So quick exam advice. Remember that you're really good at maths. The questions are going to be hard. They have to be hard. You know this, we've been looking at past questions. Which means that when you're in there, the combination of stress and hard questions will maybe briefly make you feel like you're not good at maths. I'd just like you to remember, either during the exam or maybe afterwards, I would like you to somehow try to remember that you are good at maths. And this is cheesy, but don't take it personally. It's just a test. Did you read long answer questions last year where they finished mid-sentence? Yeah, quite a lot. It was quite normal. Turns out that people just, I think, so my first theory was the people writing and stopping mid-sentence are being cut off by the timer, but then I noticed that there were candidates where there was drill on multiple questions, like both multiple parts of questions were just finishing mid-sentence, so I've learned that there are candidates who just I don't know, just we gave up with the thought that they were typing and just moved on. So, oh well. For interviews, are things like personal circumstances and predicted grades also considered aside from MAT results? So if an interview is an event, the interview is a thing that happens, but I think you mean after the interviews when we're making decisions. And yes, after interviews, we look back at everything. And we're allowed to take anything into consideration that we already did, and now we have interview information as well. During your interview, do we look at your predicted grades? No. We're in the middle of doing something that's better than predicted grades. Right, okay. What about select people for interviews? Right, okay. So we look at your, we do look at your predicted grades, of course, but that doesn't help Oxford very much, because for Oxford, everyone's predicted really good grades, so that doesn't help very much. We'll look at GCSEs or equivalent, but that doesn't help us very much either. We look at MAT scores, which is why I've done a MAT live stream and not. Why GCSE? Would a GCSE live stream? It'd be a bit late now, wouldn't it? But maybe for the people, GCSE live stream. I don't know. Watch this space. I think we may have just invented a new live stream live on chat. Rob wants to know if they're predicted grades. If your predicted grades meet the grades that we're looking for the course, that's considered good. Because we could make you the standard offer. You don't need to exceed them. There's not a sense for maths admissions, at least I can say that having 3 or 4 A stars is somehow better than 2 A stars. I mean, it's harder to achieve, but we don't think it tells us more information about how you will do on the maths course. For other subjects, maybe. For other subjects, they probably don't care. I don't know. Other subjects are not watching this video, are they? Maths, 2 A stars is already enough, thank you. Right, okay. I am trying to cheer you up. I suspect that chat might have actually been sarcastic. Do I do my interview with someone from the college I have chosen? Usually, yeah. Usually the college that you've applied to will be the ones in charge of that application in the first instance. Usually they will do the interviews. If you're interviewed for maths at Oxford, you almost always get interviewed by another college. So 2 different teams. But yeah, if you're applying to a new college, then new college tutors would like to meet people through interviews. I hope everyone's applied, Kay. It was the UCAS deadline for Oxford yesterday, so I hope they've applied. Who knows? What type of candidate would you get? An unconditional offer, one who has already met the grades. So maybe someone applying during a gap year, or someone in the US who had already done their APs, but there's almost nothing. There's always no danger for us if we think you're going to make the predicted grades, we might as well ask for them. And surely you think you're going to make your predicted grades as well, right? So that'll be fine. Why do different courses have different mean acceptances? Got different applicants. We look at the courses separately. So we want a certain number of candidates for each of the courses. We've got a bit of flexibility, but they do have different average scores. Hey, there's an anonymous new college applicant. That is the correct way to do it, because now I don't have to disclose it. Oh, brilliant. Okay. I'm applying to new college, but they are correctly anonymous. So I don't have to go to my new college tutors and say, well, there is one applicant who is known to me. Had to do this before. To be like, oops, whoa, I just dismissed someone's question by mistake. I'm really sorry. I clicked the wrong button. Can I get it back? I'm doing it. That's dismissed. Yeah, that was me. Okay, I dismissed that one by mistake. This is a bit chatty, isn't it? Should we do some maths? Ooh, how to get a bit better at explaining reasoning. I find that it's helpful to think about something 2 ways around, to try and think of new words in my head. There's a danger there, of course, of rephrasing it, that I might type something quite incoherent where I've mixed up my language, but I find it helpful. So something I didn't do when I was a teenager, but I've started trying to do now, is to think about my solution again, but in a different way, or using different words to describe it. I have come to the realization in older age that my first instinct of how to describe something is not always the best way. That's taken me many years to get to. Maybe that's just a me thing, who knows. Do you know if they use hires or predicted grades for Scottish applicants? We use hires for Oxford Maths. We are looking for 2 or 3, like AA or AAB. We know it varies quite a lot from school to school in Scotland. How did you get to where you are today? I did a PhD. After my PhD, I applied for a job. I am now doing the job. Well, there was a job interview, I guess, in between, but this is my job. I just applied for it. Right, okay. Do some courses just have sweatier people? And I think they... I think they mean, like... I think they mean A-level results. Some courses at Oxford ask for more A stars than others. The person asking about Indian CBSE at the top there. If you do a search for Oxford International Qualifications, there is a website listing lots of international qualifications. I can't remember the numbers. I think we accept this one. It maybe depends. There's some letters that I'm supposed to memorize that I haven't memorized. I'm sorry. There are no course-specific questions, Anna. That's right. Again, coffee cup page. Let's all just hang on. Sorry, I'm not trying to put Anna on the spot, but look, before we started doing the stream, we had to update this page with the coffee cup, and I tried really hard to update the page with the coffee cup with the sort of information so that even if people don't click on the MAT Livestream, thank you for clicking on the MAT Livestream, thank you for being here. Even people who don't have time to watch the live stream, we tried to put the information that they would want to know over here in the about the test format boxes. And then, everyone scrolls past to get to all the questions, right? Because you want to do the maths. But we have tried to put a very short primer on the left of what's going on. Things like you type your responses and all candidates should attempt all questions. Sorry to put people on the spot. Really tried with the coffee cup page. Managing time, I would probably go for the long questions and then come back to multiple choice. I promise we will do some of those in a minute, but chat's asking questions and they're still good questions. So we're doing that for a mo. Where are those revision things for the syllabus? We used to do revision questions and they grew up into the MAT Livestream. There used to be a page of questions that were like revision questions, if that's what you mean. They grew up in the MAT Livestream. I put some of them on screen earlier. And that's the MAT Livestream resources from the first half before the summer. Oh, what a big summer break I had this year! And before the summer, there were some revision pages. Maybe that's what you were looking at earlier on the stream. Web link for MAT Livestream over there. If you get 80% of the MAT, what's the likelihood you're selected for interview? Let me just look at a bar chart. Blah chart. Is that what a really boring bar chart might be called? A blah chart. Selected for interview, about 90%, I think. Reading off a bar chart on the left. Should I only do question 2 and 5? You do what you like, but question 2 and 5 would definitely not have anything in them. None of the questions have anything in them that you'd be scared of. I sort of think people do these. Mock MAT website. I don't recommend any mock websites. Who writes the MAT questions? A big team, including me. Used to be a smaller team. It became a bigger team. Part of my job is to make sure MAT happens. Anna's not their real name. Rob's not their real name. This is great. There you go. So I haven't put Anna on the spot, and I haven't worked out who Rob is. Fantastic. Excellent. All I need now is for all of these anonymous people to tell me that is their real name. Good. Yeah, okay, same style as the MAT syllabus page. It just had everything you need to know in detail for each section. That does sound like my MAT live stream. That does sound like the project we're currently doing. Sorry to get really meta, but like in detail for every section, right? So you probably don't mean the syllabus, which is the syllabus is just this one-page list of topics. We've had that for years and years. The innovation since 2020 is that we have these. Maybe you've seen them as PDF, right? So PDF has this. A little snippet of the MAT syllabus, and then more detail with bullet points. And I've also made it into a web page because I think web is slightly easier. You can zoom the web page nicely. So there's both on there. I think that's probably what you're thinking of, sort of explaining all the maths on the syllabus. Maybe you've seen some A-level guides to explain what's going on over there. Yeah, okay, so now everyone wants to know about the people with 80 on the MAT who didn't get shortlisted, and don't worry about it. I'm not going to comment on particular cases. Yeah, what's my real name? I wanted to be not anonymous, but I'm applying to you and didn't want me to judge. Oh, right, okay. One of my students at New College told me that she was switching between accounts on the MAT Livestream. She had one account that was her name, which she used for posting memes and banter, and she had one account that was anonymous. I don't know how she was managing the 2 account situation, but I found it interesting that someone told me on the course at New College that she'd been juggling 2 accounts for serious answers where you're not sure if it's right or not, or memes and banter that you would like associated to your actual name. Cool. That was my 4th year student, Anonymous. She's doing really well. Right, okay. No, there's no issue. There's no issue with applying to New College and not being anonymous. I made a joke earlier about how if you're applying to New College and I know who you are, then obviously I'd have to declare this. Like, I work at New College and you're applying to New College, I would have to say, oh yeah, I'm aware of this person. You know, if my like nephew was applying or something. So the joke is that if I knew who you were through that live stream, but then the undermining is because they were anonymous. So it's not a conflict of interest because I don't know who you are. I mean, the joke being that I don't know who you are anyway. Right, I'd be amazed. I pronounced John wrong earlier. The name was John and I just got nowhere near. Right, how can I practice math? That is a great question, which we are going to put to a vote. Chat is going to tell us how to practice maths, choosing from the 2022 multiple choice questions, which you can have on screen here. We have an equation that looks suspiciously quadratic. We have 100 circles. What a start to a question. 100 circles. We have something that looks suspiciously quadratic. We have a sequence that might be doing something or other. We have something to expand. We have sine 5 theta. I've seen this in a black pen, red pen video, labelled as an Oxford MAT question. So hi, black pen, red pen, if you're watching. My turn to do this content, maybe. Maybe not. Maybe not, he says, looking at the vote. G is this sort of super germane fact. H is some crazy logarithms. Oh, is this getting votes? No, it's not. I love logarithms. That's not a clue, that's just me loving logarithms. Okay, some probability. Somebody asked for probability. Here's a probability question. It's not getting votes either. And J is this question, which I think is going to win the vote because on the old papers like this, I'm saying old for 2022, sorry. For the old papers like this, we made some effort to try and sort the questions so that 1A would be relatively nice and 1J would not, with something in between. That usually means that when I do this vote, 1J wins is the one we should talk about. For MAT 24 and 25, some of the multiple choice questions were 2, 3, or 4, so we've actually sort of gradated that by making some of the questions worth different numbers of marks. It's indicated on the question in MAT 2024 and 25. Okay, how's this going? Is this going all right? Rob says, I don't know if I selected a college or if I did, I picked a random one. Is that okay? Yeah, that's fine. We wouldn't know, would we? If you picked at random, we don't know whether your heart's really in it or not. We can't tell. Only you can say. Maths more important than predicted grades. Yeah, I think I agree. Predicted grades is multi-dimensional, so there's different things you can mean there. But I think I know what you mean. Quality and quantity. Oh, I am losing my voice. What a time to lose your voice. Middle of 2 hours of what could maybe be described as just chat. Shall I back it up by doing some maths as well? Right, J and I is doing well on that vote as well. And chat's a fan of 3 blue, 1 brown. No, not 3 blue, 1 brown. It says black pen, red pen. Oh no. Today we have a water bottle. That's the drink of the day. You're welcome to join in with one of those or something as well. I think there are international students here. There's the chat message. Pop, I'm slightly ahead of chat. There is lag between my screen and that screen. It's very weird. High predicted grade. Right. Not really. Maybe, but not really. Your predicted grade is probably an A star anyway, so a higher predicted grade. I'm not really sure what that would mean. if we're talking about maths. If we're not talking about maths, then what are we doing here? Okay, so J has got these two equations, and you're told that there's a repeated root. And you're told there's a repeated root for this one as well, but let's not get carried away. That might not be a repeated root. They might be different repeated roots. Oh gosh, this is like those questions about, we had a question with an irregular hexagon that had all the sides the same length. And you're like, how could it be irregular and also have sides the same length? How can these be repeated roots that aren't repeated between the different parts? So, you know, there you go. But I think I get it. It means this quadratic has a repeated root. So, the tempting thing is to not read the rest of the question, but to stop here and to turn that information into facts about discriminants. I say tempting because, well, that's what you always do when you have a repeated root, I think. You write out something like, this quadratic is this plus 2mcx plus c squared minus 1 equals 0. I'm assuming that you can multiply out a square and move everything onto the left, sort terms by descending powers of x, group them together and form a quadratic. Although now that I say that out loud, I sort of consider that maybe I should have done it in more than one line, but there we go. So then maybe you'll write down a discriminant, which in this case is b squared minus 4a, and then c is not the letter c, it's all of that stuff. So maybe you'll write down this fact, this repeated root, means that we have 4m squared c squared, that's this thing squared, minus 1 plus m squared c squared minus 1 is equal to 0 because it's got a repeated root. So that's called the discriminant, isn't it? Discriminant. Ooh, spelling. Losing my voice, losing my spelling, here we go. And then maybe I get excited about this because I could cancel some terms. Oh, actually, I'm starting to think this might be how I would do the question. This isn't exactly how I would do the question. I cancel a factor of 4 as well. This is lovely. I get a factor relating together m squared and c squared. It's pretty solid. Okay, and then multiply out the other one as well and get another fact. And then we'll have two facts for m and c. And the question is going to be, what's the consequence of that? How many solutions? Although the question says, how many possibilities are there for the line y equals mx plus c, which suggests an entirely different way of doing this question. I'm going to look at chat and see if chat is telling me a different way to do this question. This is a pause for anybody who hasn't seen this question yet to have a think about what else you could do other than all of this discriminant stuff. I should have a second one on screen as well, shouldn't I? It was irregular, but yes, the hexagon was irregular because of the angles. So translation of a quadratic along the line y equals 1. I don't know what it means to translate a quadratic along the line y equals 1. Do you mean sideways, in the x direction? Along the line y equals 1, the y equals 1 line is a horizontal line. Ah, right, okay. But there's something going on with y's. There are circles in this, yeah. They're not two lines, or maybe there are some circles in here. Possibly you realise that they've been written like this for a reason. Yeah, so I suppose this is a translation, isn't it? It's sort of it's funny, isn't it? This is like a translation of the graph x squared, but then there's another one. There's like another x squared that hasn't been transformed. So that's quite tricky to think about, actually. So mx plus c would be a different quadratic with a different turning point. Multiply by m, and also add c. So it's like this one, maybe. And you want the sum of these things to be 1? That's kind of weird. I know how to transform one graph, but if you then have a different graph that isn't transformed, and you do something together, then I'm quickly moving out of my comfort zone. You could equate them since they're both 1, although careful, because I think a solution to that would be a value of x that satisfies both equations, and I'm concerned that there might not be such a value of x. Maybe there is, maybe there isn't. It's not obvious to me, but maybe these could be completely different quadratics. They are. That is a good comment. I like that one. That's going on the screen. No offense to everyone else, but come on. The number of unrelated x's in this question threw me so much is a really good comment, because yes, I think these x's are unrelated at the moment. Maybe we can relate them together, but you've spotted that this repeated root x is nothing to do with this repeated root x over here. This is something unfortunate about quadratics. If I give you a quadratic where the variable is not x, then it's actually more confusing. I think maybe the two lines, the two equations there, not lines, circles, the two equations there could maybe have different variables in, but that would be kind of weird. So yeah, replacing mx plus c with the variable y is a good idea. Partly because we've been asked about this line, so we've got a clue to think about this, and then the equation that we have up the top is telling us that x squared plus y squared would be equal to 1. That's a circle, that's the unit circle. But it's not any point on that circle that we're talking about. Remember, we're talking about roots of an equation. We're talking about ones where, well, there's some restriction between y and x. When I draw out the xy plane like this as a way to visualize that circle, I'm thinking about two variables, and I'm sort of imagining a point in the xy plane that could be anywhere. So that's my point in the xy plane, and it could be anywhere. That's not right though, is it? Because we also know that y is mx plus c. It's the equation of a line. So if I draw in a line for y equals mx plus c, well, now I know that with this point that we're talking about, I know that it must be somewhere on the line. You don't have freedom to do x and y independently. The very moment you invented y, there was some relationship between the two. And the weird thing about this is that, well, for a line and a circle, you would normally expect two values of x, or maybe 0 if the line is actually over here somewhere. But the question says that there's a repeated root x. There's a single solution for x. So I think that probably means that the line is tangent to the circle. And now we're cooking, because now we can look at the other equation as well. How are we doing? Chat's way ahead of me. Chat's way ahead of me. The chat's telling me about there being two circles, and the line should be tangent to both. Tom Rock's Maths has done it as well. That's nice. I wrote this question. Okay. So there's a second circle which also has radius 1, we'll notice over here. So this is x minus 3, y minus 1. So the first one was centered at the origin, if you put in y, and the second one was at 3, 1. So we're looking for the number of lines that are tangent to both. And now we've got a geometry question, and that's where it gets fun. Good. Okay. Yusuf in chat has got the right number. Alex, I find it hard to keep track of what all the information means graphically. The question is kind of backwards. Maybe if I start it in the other direction for you. So, yeah, let's start in the other direction. Let's say, new question. Consider the circle x squared plus y squared equals 1. And you're told that the line y equals mx plus c is tangent to the circle. What can you say about m and c? Oh, maybe this is not going to have the effect I want, because maybe you're going to go and tell me about radius and tangent. You know loads of circle facts. But one way you could do this question is algebraically. You could say, well, that line at the moment could be anything. Compared to this circle, it could be anything. We want the case where there's a repeated solution x. And generically, you get 0 or 2 solutions when you intersect a line with a circle. You know, if I put in 3x plus 2, then you can decide for yourself whether that has any points in common by trying to solve the simultaneous equations. Yeah, I think it probably doesn't. 3x plus 2 is huge numbers. Or maybe it does. I don't know. Whatever, let's plug it in and find out, right? 3x means it's more vertical, which makes it more likely. So you can do this algebraically by looking for points of intersection. And generically, when you intersect them, you get a quadratic, you get 2 solutions or no solutions. The information here is that you get 1, which means it's tangent. Why don't we draw tangents? I think I just caught up with that. Good. It feels like a bit of a guess. Yeah, well, you get the marks for guessing on multiple choice questions. So there are some lines which are tangent to both circles like this, but there's also some lines which are tangent to both circles like this, or like this. Does the line go above or below each of the circles? I don't really have the algebra for that. I drew some pictures and thought about things geometrically, like where does the line go above or below the circles? If I imagine changing the gradient to sweep around 3 different positions, I'll find all of them eventually. Thinking about different possibilities for the point of tangency going around this circle. Can it be tangent over here? No, because then the line would go off over that way. Can it be tangent over here? Yeah, I guess so. That gives me 4 possibilities. You could probably calculate them. I don't really want to. Alternative is a kind of algebra bash, which I haven't really tried. Usually an alternative way to do the question, right? So I was writing this one out, and then I kind of stopped because it was going too well, and I wanted to show you the geometry. I think possibly this is just a kind of punishment for me, because, well, imagine you tried to do the algebra, right? So it's only fair that I tried to do the algebra to make things fair. The m squared c squared is going to cancel, so I guess you do something like multiply by -1, divide by 4, cancel the m squared c squared, and then you get c squared minus m squared minus 1 is 0. That's not bad. That's not bad. That tells you c squared is m squared plus 1. I like that a lot. What does this one do? Oh, I've got to write out another quadratic. X squareds, that many x squareds, and quite a lot, right, quite a lot of these. 2mc minus 1 for the cross term in here, minus 6 over there, x, I really want to know if I can do it like this now, 9 plus c squared plus 2c minus 2c. Oh, I don't know about this, and then the ones cancel on both sides. I don't know about this. I think it was going well and is now going less well. So I want to do the discriminant, but do I really want to square this quantity? The only relief is going to be that the m squared c squared is going to cancel out again. So I'll get something that involves, oh, I just got c's in here as well. I think I might get another similar looking equation, but it's going to have c's in it as well. It's going to be a mess, isn't it? If they both have the same repeated roots, then the answer is none, because these circles don't have any x values in common, so there can't be a circle that's tangent to both. Oh, except for the value of 2 or something? I don't think about that. Whatever. Okay. Okay. Oh. Have I got chat on screen? Sorry, yes I did. Oh my goodness, I'm so sorry. I just had chat right on top of a calculation. It was a good one as well. I managed to get this to c squared minus m squared minus 1, but it doesn't really matter because then I gave up midway through this expansion. Sorry about that. Oh, somebody wants to expand the first equation and use Wiertz's formula. And expand the second question and use Wiertz's formula. I've sort of expanded it, right? I've collected terms for the x stuff, and I don't know what I would do next if I was doing this algebraically. Right, okay, that's 1J. Chat also wanted to look at 1I, which has these different possibilities. Alice and Bob each toss 5 fair coins with equal probability and with each outcome independent of each other. Most of this text exists just in case you've seen more advanced probability or statistics or something. Maybe you've met events that are not independent of each other. So we have to put this kind of disclaimer stuff on here, even though really it just means, come on, it's just like normal. But you can't write, come on, it's just like normal in brackets in a math question. isn't considered a professional. Alice wins if strictly more of her coins land on heads than Bob's coins do. We call the probability of this event P1. Game is a draw, and we call that P2. So there are several possibilities for P1 and P2. The Vieta formula is a relationship between the coefficients of a polynomial and the roots of the polynomial. It's not on the MAT syllabus, so you're not expected to know it. You might be aware that if you factorize a polynomial and you plug in 0, then you get the product of the roots, and you would separately, if you just plugged in 0 without factorizing it, then you'd get the last coefficient. It's a relationship a bit like that. There's a family of these. That's the easiest one to think about, is what happens when I plug in 0 to this polynomial or the factorized version of this polynomial. There's some minus signs. Are there marks for communication in the long T questions? And then they say, would I get penalised if my justification is long-winded? No, not for being long-winded. That's fine. I'm hesitating a lot because being short-winded might lose you marks. If you are thinking something clever and you write something that doesn't quite capture that and doesn't say the thing that's in your head, then we can't give you the marks for the thing that's in your head. We have to give you marks for the thing you wrote. So I'm pausing a lot because long-winded is probably preferable, but I mean, out of the two, I suppose the third case, P2, is just the right amount of text. There's probability on the syllabus. We looked at this earlier. Combinations and binomial probabilities. Syllabus issued 2018. Okay. Alice wins if strictly more of her coins land on heads than Bob's coins do. That's the thing that I really need to understand. Strictly more of. So maybe land on heads than Bob's coins do. So maybe Alice flips an incredible 5 heads, in which case I don't care what Bob got. Or maybe Alice flips 5 heads. So this is Alice. Or maybe these are cases where Alice wins 4 heads, but then Bob. This is a pain, isn't it? Not 5. Strictly more. Oh, so strictly more, not a draw. But now I've remembered that Bob might flip the coins in a different, might get this in a different order, and I've remembered that so might Alice. Disaster. How's chat going to help? Ruben is explaining Vieta's laws in chat. Can I shuffle this so that people watching the replay get a bit of Vieta's laws? A little bit. There you go. You get both. Split screen. Yeah. Chat's teaching maths on the right, and math questions happening above. I just need like Subway Surfers in the bottom left corner, and we've got the perfect Gen Alpha experience. Probability of a draw first is a good idea. The game is fair, so P1 should be equal to P3. There's no P3 in the question, is there? P3, the probability that Bob wins. I can't see any reason why Alice would be more likely to get more of these coins coming up heads than Bob does, so I think it's fair. There might be lots of draws. Maybe we should work out that. So P2 for draw is easier. Because it's multiple choice, finding P2 is actually enough for the question. You'll then select one of the options. But for completeness, if you're interested, once you know P2, you could work out P1 on the basis that the game's fair. The other cases are split. That's the case that they get the same number of heads each. So it's 5 heads versus 5 heads, or it's 4 versus 4, or it's 3 versus 3. That one's a bit more common because, well, they're tossing 5 coins, so getting 5 heads is kind of amazing. Whereas getting 3 is a bit more likely. So we can work out all these probabilities. In each case, we're kind of working out a probability and then squaring it because we need both of them to get that. They're doing these separate coin tossing events. We should square because those things are independent. So we should just say what's the probability that Alice gets exactly, I don't know, exactly 3, and then multiply that by the probability that Bob gets exactly 3 heads. Yeah, P2 is I think the easiest way in. Hooray! Anonymous likes what we're up to. Oh, you're still Gen Z. Sorry. I spend a lot of time working with Gen Alpha. I'm really sorry, everyone. Right. Yeah, P1 would be a bit of a mess. I was trying to start listing it up here for P1, and it would be a bit of a pain. I think you can just about do it with cases, but you end up adding together quite a lot of similar probabilities. So you end up calculating most of these things anyway, but then you know, adding things separately. What's this then? So Alice getting 3 heads and 2 tails means that I should do 5 choose 3, 1/2 cubed, 1/2 squared, and then 5 choose 3 for Bob's outcomes, and also 1/2 cubed, 1/2 squared. That second bit being probability for Bob to get 3 heads out of 5. Bob gets 3 heads. And these things are independent, so we multiply the probabilities. Maybe I imagine Alice sort of going first. Show of force. Well, yeah, there we go. I've got slightly above average, 3 of the 5 have come up heads. And now it's Bob's turn. And parallel universes or something. In some of those universes, Bob goes on to get exactly 3 heads. In some of them, it doesn't happen. But that's completely independent of what's gone on before. The coins don't affect each other. So that follow-on stuff doesn't matter before. Combinations of permutations. Sometimes the order matters, sometimes the order doesn't matter. There's a formula which involves thinking about all possible ways to shuffle everything around, and then divides by the amount of overcounting that you've done. Now the overcounting comes from the fact that if you shuffle everything around, you're imagining all of those to be bespoke and different, whereas probably you don't actually count all of those things as being genuinely different. The combinations approach is I pull 2 socks out of my sock drawer in the morning. The formula that we have for that problem works by saying, imagine jumbling all of the socks around. There are loads of ways to jumble all of the socks around, and now divide by, well, you don't care what order all of the rest of the socks are in. There's all these different jumbles for the rest of my socks. I don't care that they're just staying in the drawer. So there's some division there. And then depending on whether I care about, was the first one definitely going on my left foot and the second one going on my right foot, or was it just a pair of socks and I was just trying to make a pair of socks, tying them together so that I could tidy up this sock drawer. There are different scenarios where you might care what order this pair of socks have come out in. Nowhere in that do I care whether they're a pair or not. I can't help you match the socks. Right, is it worth practicing computer science questions? I mean, you could if you want to. I've been on the fence a bit. I don't really know what a computer science question is. I mean, I look back at the questions, of course. We've got one down here somewhere. I look back at the questions and I mean, I remember the computer science department writing this, and it does have these like words in about data operators and doing things, but I sort of think it's not too weird. This one in particular is just quite fun. So if you're a maths applicant and you're looking back and you see these past computer science questions, often I do think that they're kind of fun in the way that they don't require you to do the questions that have traditionally been put in question 6 and question 7 or old math papers. Traditionally don't require you to do integration or differentiation. So if you don't like integration and differentiation, then separately I have bad news about the maths, but maybe you like this question which doesn't involve either of those things. And long questions in 2024 didn't use integration and differentiation because you can't type an integral sign and you can't type d with dx. Maybe you can, I don't know. No, you definitely can't. You can't type. Okay. Someone says, wait, explain why. For the socks, maybe. Best way to learn more about socks is the thing I'll promote anyway. I've started too strong by saying best way. And we did have some discussion about this back in the algebra live stream, which was back in, I don't know when. No, I do know when because it's in the table. Come on. It was in June. So if you scroll back in this YouTube channel back to June to find algebra, or if you just want to read the notes, then we've got some notes here. I've got an explanation of where this formula comes from, which I found out some people learn in school, some people don't learn in school. I think it's not that complicated, so I think everyone should see it at some point in their lives. the question, computer science questions Jacob's right, they do mention robots more frequently. It's not 100% 0% for mentioning a robot in a question, but there you go. There are a limited number of questions on the MAT website. That is true. They are finite, but gosh, there's a lot. Yeah, okay. Is it okay to type if you use LaTeX? So it's behind the poll at the moment, but someone says, can you type \frac open curly bracket 3 close curly brackets open curly bracket 2 close curly bracket instead of 3/2? And the answer is yes, you can. The markers will know what you mean. It's not going to get compiled. If you're hoping that you type LaTeX and it gets presented as a fraction, that's not going to happen. We're not expecting you to know all of this \frac stuff. So it would be equally acceptable and probably faster to type 3/2 if you wanted to present the number 1.5, or 1.5, or one of those. Some of those might be fewer keystrokes. There's no round of math jacks or something going on here. It's just the characters that you put in. Oh, I knew this was coming. I've been preparing for this. It's finally happened, chat. Somebody has rocked up to the MAT livestream. This is all time. Stop the clocks. They've rocked up to the MAT livestream, all excited. They've logged in anonymous, and they've gone, "Is 6.7 a good MAT score?" They found a way. I've been waiting. I've seen the meme coming through younger year groups. To have it finally here at the MAT livestream. You are Gen Alpha after all. I was right all along. Oh, good. I'm so pleased you're here. Right, people have voted for question 5, which is just over here. Said with confidence, but not with accuracy. That's the door game. Yeah, 69 would be a much nicer MAT score. Here we go then. Let's get off this. Let's go do some question 5. There we go. Right. Let's hide chat a bit. What are we doing? Oh, it's 10 to 6. No, we're good. We're doing a question. I tell you the other thing. CS questions often got robots, often got reading. Time for a TV game show. Right, we're picking doors. Maybe we're going to win some sort of goat. That would be my preference. The door is shut again. The host secretly swaps the item behind door I with the item behind one of the neighbouring doors. If Alice picks door 1, the host has to then swap the item with the one behind door 2. And similarly, if Alice picks door N, the host has to swap the item. I think the challenge here, really, at least to start off with, is to come up with a good way of scribbling notes to yourself to keep track of what's going on. There's a concrete example here. I don't think this is how I would scribble it down myself. That's how it's described in the question, but we don't have to do it like that, right? Suppose N is 3, and if the original items behind the 3 doors were A1, A2, A3, well, none of those look like a goat, but hey, maybe A1 is a goat. First, Alice picks door 2. Alex in chat distracted me. Then the arrangement after the host has swapped items could be either this swap on the first couple, or it could be that swap. That Alice has seen what's behind door 2, and the host sort of panics and moves it one way or the other, doing a swap. So if Alice was allowed to pick twice, had she chosen door 2 followed by door 1, in the former case she gets the item. Alice wins all the items that were revealed. All right, okay. Chosen door 2 followed by door 1, haha, the host has tricked you. Only getting the item A2, which you saw twice. Alice's aim is to find a sequence of door choices. Should we play with this a little? So you've got 3 doors. I draw doors, numbered 1, 2, and 3. And Alice opens this one, and then the host does some sort of swap like this. So maybe I want opening to be some sort of blob for you looked in this one. And then there's a swap, and then Alice maybe looks over here, and these are connected, so Alice sees the same one. But there's another possibility that the host did this instead, so then Alice looks over here and wins a different thing that was sort of unrelatedly not moved. I don't know, maybe I'll stick with blobs for Alice looking in a door. This is a bit daft, right? Because I think Alice could look in door 1. What happens if Alice looks in door 1 instead? Well, then the rule is, if Alice picks door 1, the host has to swap the item with the one behind door 2. And Alice knows that. So after doing this, Alice could now open door 1 again. And that's a different thing. And the host will have to do a swap back like this. As I'm using this kind of cross to indicate a swapping thing. And then Alice could look in door 3. Because that one can't have moved yet. There's only one swap going on. So Alice would end up with all 3 items in that case. Okay, cool. So questions 6 and 7 are clearly labelled as being for computer science people, and question 5 was often written by the computer science department. This is why I don't really believe in computer science question right, because I know in my head that this one was written by the computer science department as well. We made everyone do it. So for me, the concept that this year there are questions that everyone's answering, sort of like, yeah, I've been doing a bit of that as well. Yeah. Oh my goodness. Was it a setup there? Oh, chat's gone again. Oh. Maybe it was a setup. Maybe the question was, this is what I really want to know. What level are we working at here? If somebody says which questions used to be the CS questions, are they trying to set up the 6-7 joke, or are they genuinely asking me a question about the test that I organise? What are we on? What level of trolling is chat reached? Oh, is this punishment? It's like in advance that I'm going to go mad. Right, okay. For n equals 13, give an increasing sequence of length 7 of distinct doors that Alice can pick that guarantees she wins 7 items. 7 doors, 7 items. We need to make sure that Alice sees something different every time. That sounds quite hard. Because once you've seen something, it might move with you. So it might go there, or it might go there. We don't know. It might move. It has to move one way or the other. So we kind of need to avoid that. Thoughts. 13 is about twice as big as 7. So can I do something where I pick and they move 1 square along, right? I was able to, in this kind of example that I made up, I was able to end up, item 3 didn't move at all because I was just, I can open door 1 loads of times, and if I keep opening door 1, the things between door 1 and 2 just swap backwards and forwards behind. So if I keep opening door 1, I'll only see those 2 items. But none of the other items are moving during this ridiculous process because the moves are quite small. So my first thought is, can I open 1, 3, 5, 7, 9, 11, 13? I think these are all good, right? Because after I've opened door 1, that's going to move. I know what's going to happen actually. It's going to move to door 2, so I'm going to ignore that. I'm going to move away from it. And then maybe if I open the thing door 3, I know that hasn't been disturbed yet, so it's a different thing. And then I'm going to generalize this. Every other thing. I know that there's kind of a wave of disruption that goes on here. Like I'm running down the corridor, opening every other door, and the host is frantically swapping stuff, but I've run away. I've gone past all of that thing. So after I've opened door 9, the host's like, oh, maybe I move it to 8 or 10, but I don't care. I've already moved on. I'm already over at door 11, ready to open another thing and see another prize. And they're like, oh, shall I move it to 10 or 12? And it doesn't matter because I'm sprinting off down the hallway towards door 13. And I will keep going as long as the corridor of doors keeps going. So 2k plus 1. I can do this. I have gone in a silly mood. Yeah. Yeah, that's a strong effort, Aaron. I appreciate that. Is there no more specific questions from after 2023? Yeah, after 2023 we got no subject specific stuff. This was a thing we stopped doing. Yeah, so why wouldn't you pick door 1 twice at the beginning? That's a great question. I liked doing it over here because door 1 twice. I get both of those prices and nothing else has been affected. I think that's going to be the answer to the next part. Probably. I think that's a really good idea. Because then you can move on, right? Maybe you can't move on so much, right? Because you're relying on the fact that door 1 is on the left. So you will pick up 2 prizes from here, but then now you've got a problem, because you can't just treat door 3 as the new door 1, because now stuff can actually move left. So picking door 3 twice, it might switch with one of the things that you already saw from door 2. I'm not moving right fast enough. Yeah, so if you go in the first part, it does say an increasing sequence. Later on, that word disappears. So maybe down here, I think the suggestion is that we do door 1, and then we have a think. So we pause here and pick 1 twice. Yeah, so Samuel's suggestion in chat is that maybe the right move is not door 3. Door 3 has this kind of jeopardy that we can pick door 3 once, like we did there, but then we get confused that now we've kind of disrupted stuff up to door 4, so I don't really want to pick door 4. I'd have to go on to door 5 and do something like that. So I think this helps me get a sequence of 8 doors, but we can do better. So I think this sequence that Sam's doing in chat, sorry, Samuel is doing in chat, is like this. Ruben's added 7, 7 in there. So these gaps are kind of large enough that you pick door 4 because that's undisturbed, so you're going to get a new prize. And then the thing it swaps with was also undisturbed. It was either 3 or 5, but we haven't gone anywhere near 3 or 5 yet. So that thing swaps in to door 4. You pick door 4 again because you know there's been a swap, and then you move quite far away. You can't go and look at door 6 at the moment because door 5 might contain one of these things you just saw, and we want all these things to be different. So I'm hoping that this is the right length. I'm adding 3 each time, so 10, 10, and then last door twice. And this time around I can do the last door twice because I know that door 12 up till now, up to here, door 12 has a new prize in it that I haven't yet seen for sure. Because at worst door 11 has been involved in some swapping shenanigans, but door 12 is untouched. I'm not going to go and look at it straight away. I'm going to wait for the host to move something into it for me. So you see, they have to do a swap. I think that's up there somewhere. Beforehand, it's dangerous because let me draw you the last section of doors. In the previous case, here's my plan. 9, so doors, ... 9, 10, 11, 12, 13. And we've done lots of picking, but then we get to sort of door 9, and let's say the host moves that one left. Fine, okay, I've gone over here, open door 11, and the host goes, oh, rats, okay, right, I'll swap that with door 12. See, now this is dangerous for me, because I can open door 13, that's my plan, get something new, but now the host has this option to do this swap between door 12 and 13, and hit me with the thing, if I pick door 13 again, hit me with the thing that I already picked from door 11. And the fix here is to open doors further apart, to essentially forget this for now, and move this structure 1 door left, so that the host can't move the thing right enough, fast enough for me to come, far enough for me to come and see it again. So now it can't be the same item. They're separated here, so I am now happy. I'll make that into a happy face. Yeah, oh, now I need to think about 1, 1, 13, 13, 3, 5, 5, 7, 9, 11. Oh my goodness. Okay, they're quite hard to check. Marking this is pretty tricky. Advice if you don't really understand the wording on a long question. Often the first part of the question is there to help you develop your understanding. So here, maybe you think this is impossible, in which case I'm afraid it's a kind of reading comprehension test where you've got a couple of paragraphs to go and look at, and you've got to work out why maybe you think it's impossible, the question seems to think it's possible, so you've got to work out where that distinction is, what's the difference. That is nothing to be scared of. because that is kind of a fundamental skill in maths and a bit in computer science. To have some complicated setup where you need to understand what's going on, and that involves maybe having a stab at it and trying to understand it, and then going back and refining your understanding if it's not quite gelling with what reality appears to be. Step marking. So someone said step earlier, but I think they mean here you solving the shortest lines. There are words in question sometimes. So justify or explain means you should say why something's true. So here in this question, it says just give a sequence. So that's okay. I can just give a sequence. In this part, it doesn't just say give a strategy or something. It doesn't just say give a strategy. It says briefly justify your answer. Good news, this one says briefly. So in that question, there are some marks for explaining why as well. For long questions in maths, you should expect to explain your answers. That's what it's doing. Kind of a quicker solution if you want to. Is there error carried forwards? Yeah, sometimes. I can't imagine how error carried forwards would work for this question. If you're sort of wrong in part I and then you generalize it to something that's also wrong, I wouldn't expect to get marks on either of them. So it's sort of not really for a question like this. I can't really tell what that would be. But occasionally in the past we've had questions where you do a big calculation and then you need that number. So some amount of that maybe. But yeah. Partial marks for partial explanations, yes, for the long questions. Okay, there's more of these. So we generalised that one as well. And then we do some small cases, right? So for 3 items, actually already did this one. 1, 1, 3 is good. Because we checked that picking door 1 first just feels like such a good move. Yeah. So what do I feel about here? 1, 1. I also quite like 5, 5, and 3. Does that work? So 1, 1 gets the things from 1 and 2. 5, 5 gets the things from 5 and 4. And then door 3 hasn't been involved in any of that swapping yet. I guess it's still got the thing that started there. Yeah, I could do that in any order, I think. You get some for paper in the test room. You get this sort of laminated whiteboard stuff. You get 10 sides of it, I think, in the first instance. I'm not sure. And there's a system to request more. So in some sense, functionally infinite. The system is you put your hand up and you swap the stuff that you're finished with. You give them that booklet and they give you a different one. Whatever it is. Is there mechanics on this? No, there's no mechanics. Good news. I love a bit of mechanics, but not on the maths. You see, it's not a clue. I sometimes just tell you topics I like. 3 must go last. Oh yes, I shouldn't mess with door 4. Yeah, you're right. Yeah, good point. Thank you. Oh yeah. Sorry, I have to scribble all over the question because I am. The artificial thing here is that I'm also live streaming, so I have to be able to show you all of this stuff, and I only get maybe just a mobile phone sized amount of space if you're watching on a phone. It's probably not going that well if you're watching on a phone. Sorry about that. I'll try zooming a bit more. The artificial thing here is that I have to answer questions in this ridiculous way where I write in between the lines of the questions. That's not you. Right. You can't erase, but you can request more blank. That should be different. Yeah, it also limits how much I can write on the stream. It's also a long time since I've written out solutions properly on paper. Long time since I've done an exam. Oh no, Tamua didn't do it right. They do. No, Tamua would have done it right. Oh, they take your current whiteboard. Right, okay, well, let's highlight this. Fact about Pearson test centers. There's a system to get more of the whiteboard stuff, but it's a swap system that they take the whiteboard stuff that you've got and they give you a new blank one. Right. Do whatever it takes, I guess. Is it worth taking 4 A-levels? Well, okay, so if you're applying for Oxford at the moment and you've told us you're doing 4 A-levels, then haha. At the moment, we believe that you're doing 4 A-levels if you've applied to Oxford and you're doing 4. Our standard conditional offers are based on 3, and if you get made one of those standard conditional offers that asks for 3 A-levels, if it doesn't specify a grade in your 4th A-level or say that you have to take the 4th A-level, and then technically you can legally meet that by doing what it says. And if that's 3 A-levels, then that's 3 A-levels. There are other reasons why you might enjoy doing a 4th A-level, but definitely not if it's going to stop you getting A stars in maths and further maths. There we go. I was glad people have now done the Tamua. They've learned maybe how the system works, or at least they can tell me how the system works. That's the fun thing. Right. I don't think I'm going to do these strategies at the end. I think I'm going to switch to a different paper. There exists a better strategy. A sequence of 11, length 11 of doors. And I think these last 3 parts are very hard. Especially this last one. I can't even... Off the top of my head, I can't remember my answer to this last one. I should have written it out. There we go. Rob, we're pretty keen on people being predicted an A star in further maths. If you're doing further maths, if you've got further maths. Oh, somebody's gone back. How have they done that? Anonymous in chat. 1155 99 13 13 3 7 11 1 2 3 4 5 6 7 8 9 10 11. So I've gone further apart. Messing with 2. I'm messing with 6 and 8. Oh, it's kind of a version of this. It's a version of this. I should have looked back up and thought, can I do this going back? Lesson for me. Lesson for me. Generalise the thing you just did. 1155 is a good start because, as Rosie told me, you've not disturbed door 3. You know it's not going to be a problem. Yeah, then there's some game 3 at the end. 1 1 3 5 7 9 11 13 13, and then 6 and 8 left over at the end. Why are 6 and 8 left over? Yeah, Ruben, I'm quite worried that door 6, when you open it, will contain the same thing that you saw when you opened door 5. Oh, but maybe not. But then, if it does, then you don't. Oh, you've done. Okay, 1 2 3 4 5 6 7 8 9 10 11. Yeah, no, I can. Is it necessary to do all the steps? And nobody knows what all the steps means, I think. I don't think there's an agreement about what a step is, right? Maybe there is on your exam board for your school leaving qualifications, but internationally there is no agreement about what one step of calculation is. I had a kind of almost a joke earlier where I wrote out this, and the joke is that, well, when you square out, several things have happened here, right? I've squared, I've rearranged, I've moved things onto the left. Maybe I should do this in slow motion, right? So maybe the mx plus c squared, maybe I should multiply that out first by telling you that this is mx plus c times mx plus c times c, right? And then multiply these out to tell you that it's mx times mx plus c times mx plus mxc plus c squared, and then tell you that it's... But obviously nobody writes out any of this because everyone just is capable of squaring that straight away, and probably capable of doing more stuff as well. But when you're doing stuff like this, there's no concept for us of what it means to do every step, because the number of steps you're taking is how much you're trying to demonstrate to somebody. Somebody gave me this metaphor once about explaining mathematics, about building a little staircase. They say, when you're building a staircase for a giant, you put massive steps in, so that the giant can take these huge steps going along up the stairway. But if you're building if you're building a staircase for I don't know, tiny little bunny rabbit or something, then you have to put in tiny steps. You have to take those big steps that you put in for the giant, and you have to sand them down and put in lots and lots of tiny steps for the little bunny rabbit running alongside the giant footsteps. The rabbit needs more steps there in order to get to the same place. But there's not a fact about, you show all the steps. What would that be like? I guess some sort of ramp. Right, okay. Step is real maths, IMO, and then Matt is multiple choice, which is not true. Matt has got long questions as well. G'day. Right. Yeah, I shouldn't have picked rabbits. Why did I say rabbits? Rabbits can jump. Famously jumpy animal. It would be worse if I'd said a flying animal, I think. Wait. Which sine cos tan value should I memorize? Oh, right, okay. The ones that are like 30, 60, 90, 45, 0. You can probably work out other ones from that. That'll do, I think. Yeah, 30, 60, 90, 45. That's not in order, but yeah, the ones that are like 0, 1, root 2, root 3. It's not root 3, is it? It's root 3 of 2. Okay, right, those ones. There are no hyperbolic trigonometric functions on the syllabus. The syllabus is one side of A4. You can search it with your eyeballs extraordinarily quickly. 22.5, half angle formula maybe. Half of 45, I don't know about that. Right, it's 6:15. We could look at some 2023 questions, I guess. What have we got in 2023? We've got 10 multiple choice questions that we could look at, including some really awful integration if you pick J again. We've got some long questions that maybe we could have a look at the long questions maybe. There's even this 6th one involving trees. I think we'll do a vote on. I feel like a multiple choice question just for a moment, having just told someone quite tersely that Matt is not multiple choice. I now get to do a multiple choice question. I think just for fun, and answer some chat questions. We've just gone past 300 chat comments for today's live stream. Do you need to know sine of a plus b? No, it's not on the syllabus. Do you need to know about asymptotes, how to spot them and all? No, it's not on the syllabus. Although, I mean, you know the graph of 1 over x. Well, the graph of 1 over x is on the syllabus, and it's got an asymptote. I don't think you need to know the word asymptote. You obviously do. You've used the word asymptote in your chat comment, but you'll be right. These are hard, aren't they? So H is getting votes. Let's put H on screen. Oh yeah, H is pretty hard. 2020 question 2. Have I got it on my Miro? If I've got it in my Miro, I'll go for it. 22. And there was a long thing with there's a long sequence that somebody wanted me to check, right? And they said, or is this a stupid question? And I think it's probably not a stupid question, right? 1, 1, and then they go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The problem with this 1, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is the host can swap the items to keep moving one particular item, maybe it's the goat, to keep moving it along one door every time. So you open door 3 and they can, it's the goat. Okay, well, you win the goat. And then they do the swap and they move the goat. They swap it with whatever was behind door 4. So then when you open door 4, you see the goat again, and then the host gets you a further 9 times. So not a stupid question, but you've got to imagine that the host is pretty cunning and that they will try and do other stuff as well. People requesting particular questions, and there's a suggestion that I put the syllabus on the MAT page. Oh dear! Put the link on the screen. Is the suggestion in chat? I do seem to mention the syllabus quite a lot. Oh, it's a binary question. Rob's requested the binary question from over here. It's a faff down here. There's a lot of things. It's to do with how things are related to the previous parts. But I see now that you've requested that I zoom right in on this question because, in a fantastic use of Jan Alpha's favourite meme, you have found a past Matt question with the number 67 in it. So, round of applause for Rob. Well done, Rob. Right, I'm taking a quick breather. That's amazing. there's a very particular rake that I keep stepping on. I've designed this entire experience so that I have a key vulnerability. Maybe you've discovered it already. The key vulnerability is that a kind of joke disguised as a sincere maths question. I step on that rake every time. 2024 was the first year the MAT just had this kind of online test centre experience. 23 is something strange. Right. Why I've got 24 more. Don't step on the rakes. Rob now says, nope, ain't no way. Should we actually do it? Should we do that part? See, I'm going to step on it again because now Rob's acting all sincere in chat, like Rob actually wants to do this. Which is a definition to show that there's only one combination of f's and g's, where f is this function which doubles a number and adds 1, and g is a number that quadruples a number. The question makes you think about binary, and then by messing around with the expressions, you maybe realise that g writes 2 zeros on the end of a binary number, 0, 0 on the end, and f writes a 1 on the end, which means that when you see a number that's been made, a number in S that's been made by some combination of these processes, it must be a sequence of 1 or 0, 0. The 0 zeros have to come like that together. And you can read left to right to work out what's happened along the way. Or working backwards, you can work right to left. If the number ends in 1, it must have come from F, not G, because F produces odd numbers, G produces even numbers. So if the number's odd, it's come from F. If it's even, it's come from G. And then working backwards, well, look at the smaller number that you had before you applied F or G. Where did that come from? Is it a 1 again on the end in binary? Is it odd? Or does it have another couple of zeros? That method of building it backwards is also what's going on for these like really tough parts of questions at the end here. So that was fun. They're all trying to get you to think about these ranges so that you can think about where the previous number came from. Did it come from the kind of the previous range here of numbers about half the size, and you applied F, or did it come from the range kind of 2 ranges before this relationship? Let's use the pen. Did it come from like this relationship, UK to UK plus 2? These numbers are about 4 times as large. If I put in k plus 2 in the powers up there, zooming, did you apply G to get from a number in that range to a number in that range? I'm not quite being precise. When I point at the terms and I say range, the term here is actually the count of the number of elements of n in that range. But I'm trying to associate the stuff together in my head, so sometimes I just not precise. Point at the count and remind myself which range it is, because that might remind myself why it's there at all. Okay, if you do right. There's some votes for 1H on 23. Oh, the wheel's coming off a little bit. I think the votes might be for this triangle question, so we might be about to find this really big triangle. If you do MAT with a reapplication for Oxford, do they see the previous year's MAT score? No. We don't connect applications together from a previous year. So you could apply every year to Oxford, and would we work it out after a while? We wouldn't link your MAT scores together. Right. We're now looking at 2023. We had a brief look at 2020 because it contained a funny number. But we're back here looking at 2023, question 1H. Here we are. We don't really have a recommended time split, but I'm going to just hide chat again because it's... There we go. Yeah, I would probably not use Heron's formula on there. There's an example of maths that's not on the syllabus that's probably the opposite of helpful. Okay, what do these triangles have in common? They have 2 sides the same, and then they have this kind of third side. So it's 10-10-1 triangle, looks like this. The 10-10-5 triangle is a little bit wider. The 10-10-10 triangle, 10-10 triangle is equilateral. So I've gone way too far there. I've drawn that 5 longer than that, but that's my 15. Which is larger, 10 or 5? Oxford mathematicians are not sure. Don't clip that. 10, 10, 10. Oh, it's smaller than 1 now. Let's get these in the right order. There we go. That's somewhere in between, maybe. 10, 10, 5. I've drawn it much smaller than the previous one, but I'm trying to draw this like thing that's getting flatter and flatter, if you like, wider and wider. So obviously this last one is the widest triangle. Is that good? What was the question? Oh, largest area. So how are we going to do this? Rob's going to try the 21 paper. Nice. Yeah, so we know several formulas for the area of a triangle. We know this half base height thing, so we could drop a perpendicular line down here. We could divide all these numbers by 2 and think about multiplying that by, oh, I don't know the height. I don't know any of the angles. Oh my goodness. And there is a formula for the area of a triangle when you don't know any of the angles, but it's pretty messy, so I would not recommend it. Instead, yeah, so split into right angle triangles and compare. The challenge there is that, well, I guess you can work out some of the side lengths. It's becoming a popular suggestion in chat. What's this then? So this is, I suppose you have width. If I call this x maybe, then this thing up here would be root 100 minus x squared or something. And then the challenge is to multiply those things. Oh, I don't like that very much. Where x is that number divided by 2. I don't know. Yeah, you can put some right angle stuff in there if you like. There's another way though, right? Kay's got it in chat, and I saw someone else as well. Yeah. Yeah, there's another formula, which is the half AB sine theta one, where theta is the angle at the top. Of course, we don't know theta in any of these. We can dream, because in each case there, A and B are both 10. So this is just 50 sine theta. So which has the largest sine theta? And it's multiple choice. And I'm not sure we're going to calculate any of these. Well, okay, so we know for the equilateral triangle, if you like, actually there's many ways to find the area of an equilateral triangle. I told you in the first live stream I love drawing arrows. Look at all these arrows I've got going on. We could do, for example, this one would be 50 sine 60 degrees. 60 degrees is one of the angles that I think you should know. Maybe I should know it as well. Is it root 3 over 2? Yeah, I think it might be. So that's one of them. Of course, that's the one that's easiest to find. There's someone in chat who thinks maybe this is just obviously the right answer. But I kind of want to get... Sine theta is maximised, of course, if theta is 90 degrees. That's the maximum of 1. Why have I put an arrow on that? As you change theta, I really didn't need an arrow. I'm deleting that one. There's the maximum 1. So maybe I want theta to be close to 90 degrees. In the equilateral triangle, theta is only 60 degrees, so we're not living up to our true capabilities, perhaps. The absolute best would be if there's a right angle here, and this is 10 times the square root of 2. That would be peak area. We'll maximise that. Someone in chat says, let's draw them relatively to scale. You could actually have a go at that if you like. The 10, 10, 15 one is quite hard to draw. And then I guess I want to stop doing this question, I think, because, well, 15 is pretty close to 10 root 2. 10 root 2 is about 14. 15 is pretty close to 14. I definitely don't think it's 10, 10, 19, because that one is really wide and that angle is much larger than 60 degrees. I think it's larger than 90 degrees. Can I work out that it's larger than 90 degrees? I suppose I could start doing some sort of cosine stuff, couldn't I? I haven't thought about that before. maybe I can start doing some cosine stuff. Why am I not doing any cosine stuff? Largest value of sine means the smallest value of the absolute value of cosine. Because of cos squared plus sine squared. I've never thought that before for this question. Bear with me, chap. We're going to do a thing. Yeah, how did you get 10 root 2? Well, this one is like a 90-degree right angle thing. So I'm imagining a right angle triangle. It's not one of the options, so I can't pick it, which is irritating because I think it would be the largest isosceles triangle with sides of 10, 10, and something else. If there was like a write-in option, this is not a thing, but if there was like a write-in option, option F, which said an isosceles triangle with side lengths 10, 10, 10, blank, fill in the gap, number y, I would write into that gap 10 root 2. That would be my pick, and then I'd pick it as the largest, right? If I could write in an extra option. But I can't, so I'm at the moment I'm picking something that's kind of close to that. 15 is pretty close to 10 root 2 because root 2 is about 1.4. Are you expected to know that root 2 is about 1.4? Probably not. Root 2 is about 1.5. Seems reasonable. Yeah, so people are leaning towards D. Yeah, should we try and check that? This might be a mess. I've had an idea that maybe I could, for the skeptics who don't want to approximate root 2, I think maybe we could do a quick calculation over here. It's going to involve cosine, and it's going to involve the cosine rule. And I think I am going to call the other side length y. But my plan is to find cosine of this angle and try and convince you that cosine is really small for this triangle. Therefore, sine is quite large. That's my plan. Yeah, we could compare the squares of 15 and 10 and 19. It's not the one that's numerically closest, it's the one that's got the closest sine, or the largest, like there's a distorting effect by the sine theta, not just, maybe not the one that, oh no, it is the one that's closest to 90 degrees. Can you compare the squares? No. Okay. Yeah, okay. I'm gonna quickly do that cosine thing that I said I would. Chat, bear with me. Here we go. This might be awful. So I've got theta. Oh, sorry for shaking the screen around. I thought I'd zoom in. So we've got y squared is b squared plus c squared minus 2bc cos theta. So what I need in each case is I get cos theta is going to be. Oh, this is lovely. Isosceles triangles are great. Why don't I do this calculation more often? Like this. So candidates for y, by the way, we're thinking about 10, 15, and 19 behind the scenes. I guess I could square these numbers. Ooh, don't really want to. For example, this gives values of 1/2. Or if you put in 15, then you're subtracting. Oh, I used to be much better at squaring numbers. Where's that gone? 2t5, so negative 1 part in 8. Or 19 gives me 361, which means I have minus 161 over 200. That one just looks miles away. And then my plan is to say, well, cos squared plus sine squared. I can actually probably calculate sine squared if I have to. I did not expect to be able to calculate sine squared for these triangles. This one's not a surprise. This one's sine squared. You square this, you get 1/4. You square here, you get 3/4. That's the root 3/2 factor that you knew before. This one's good because you get 63 over 64, right? You square this, you get 1 over 64. So sine squared must be 63 over 64. This one I'm not going to square that. But observation, this value of sine squared theta is way larger than this one. Don't know what I'm doing here. I've got an X inside some brackets. Wow, not close. Okay, that's how I would do this question now. That was easy. There you go. Right, okay, I was pleased with that. I don't really mind if anyone followed that or not. That was mostly for me to prove to myself that I could show you that sine theta is way larger for this triangle based on calculating it using cos squared and sine squared and the cosine rule. I'm really pleased that worked. Did that actually work? Maybe it did, maybe not. I'm going to check it again in my head by thinking really hard. If I squared 15 correctly, that would be very me, wouldn't it? 150 and 75, 225 minus 225. 225 is 1 part in 8. I should probably just stick to the ways of doing the questions that I was aware of before I started the live stream, but let me live a little. No, chat says do J. Right, okay, let's go and do J. Oh, J's fine, isn't it? I mean, it's awful. It's like several functions all at once. Here we are. 1835, good. Time check. Okay, we'll do a little bit of this really quickly. To understand this question, you need to understand when log 2x is equal to a whole number. That's something to do with powers of 2. And then in between, this function is actually constant value in between those points. So we have powers of 2. The ones I'm interested in are the, can I call them powers of 2? The ones that are really small, close to 0. Because those ones, there's lots of kind of 2 to the minus n in there. And this floor function will take a whole number, but will be constant in between. And then what have we got? We've got the number 3/4 raised to that power. So I have some sequence of rectangles, flat tops on the rectangles, because that log bit with the x in it, the only place the x appears, up in the exponent, up there, is constant once you've got around to evaluating floor of log base 2 of x. So flat tops on the rectangles, loads and loads of them going into the left. Each one, I think, is 4/3 as tall as the one to the right. And they get taller as you go in, because this is getting more and more negative. I have these things 2 to the minus n, so this will evaluate to minus n, minus n, minus 1, minus n, minus 2, and so on. As I get closer and closer towards 0, 4/3 as tall, but half as wide because of how powers work, which means only 2/3 the area. So on the way in, you get this geometric series of areas for the areas. So we can actually sum all of those up. The area here is made of lots of rectangles. The rectangles have areas that fall in a geometric progression, and you can sum a geometric progression to infinity. Good. There is finally a geometric series in there. This is not the trapezium rule. There are no trapeziums, only good old-fashioned rectangles. I can't remember the answer at the end, but maybe I can work it out. So 2, which way around the floor work? Log base 2 of 2 is 1, and that gets rounded down to 1. If I put in the number between 1 and 2, then this is somewhere between 0 and 1, so it gets rounded down to 0, and then I see the number 1. So this sequence starts with a huge square with height 1 and width 1, and then my 2/3 rule kicks in like this. So I think that is going to be 2 at the end, because it's 1 over 1 minus a third, which is, no, 1 over 1/3, which is 3. Yeah, 3. I think it's C, but I'm not sure. Okay. The graph thing, so on the left it's lots of rectangles. Often you see questions like this with this thing which rounds down, and this is a technical description of what it means to round down, I suppose. Often you see things like this combined with integration, because it always looks scary, but it always means add up the area of some rectangles, because this thing tends to give you flat tops on rectangles, so that what could have been quite a scary function is actually just a bunch of rectangles. And you know how big the area under a bunch of rectangles is. Okay. Somebody anonymous here says, thanks for running the live. I tuned in last year and I saw lots of improvement, lots of interesting maths, and got a score I was happy with. That's fantastic. There you go. where did I get the SF from? I don't know what SF means. I don't know what SF is. Cool. Oh, scale factor. I rushed this a little bit. The thing that's changing is that this is changing from like 0 and then it's -1 as you get closer towards 0, and then it's -2 for a bit. You know, log base 2 of these really small numbers, like 1/4, -2 or even -3. So this is ticking down through the numbers, which means that the 3/4 is being raised to a more and more negative power. What's the difference between 3/4 to the -2 and 3/4 to the -3? Well, it's a factor of 4/3. The negative powers are making this thing work out to be larger by a factor of 4/3 as high. So this next one is 4/3 as a height. I guess I marked that on my axes somewhere like here, and then the next one's 4/3 squared, which looks like a series that won't converge, but each one is actually getting more and more narrow because these things come every power of 2 going down. I'm going to watch the live stream every year for fun now. I don't know. It seems like it get boring fast. So again, 4/3 as tall, but half as wide. So the area has a scale factor of 2/3. These rectangles, I've tried to draw them look more skinny but taller, which is how you can fit infinitely many of them in going left. They get very narrow as well as getting very tall. The output of the functions, you can evaluate it, right? They're just various numbers. That looks really hard, but of course this there are loads of things that you might get when you do log base 2 of a number. Loads of things. It could be almost anything, right? But then when you calculate this thing with the squarish brackets, that is the largest whole number. So in particular, it's a whole number. There's not very many of those. So this is what I mean about having kind of flat tops on the rectangles. He says trying to draw a rectangle with a flat top over here. Oh my goodness. Let's square that off. There we go. In between 1 and 2, log base 2 of x is changing loads, but the largest whole number that is less than or equal to that isn't changing as you go between 1 and 2. So the function is constant, which makes it easier to integrate. Good. So 2/3. There we go. Okay. I don't love the long questions, and I think the answers are pretty good. So instead of doing our normal poll, there are web solutions for 23. I'm going to leave it to chat. I know we can structure this, can't we? I can do this. We've got 20 minutes on the stream. So we've got 2023 has a question 2. But there's also 2023 has a question 3 and a question 4 and a question 5. But not a question 6, but not a question 7. Oh, I thought this would be easy. Why did I think this would be easy? Question 6. But then I cannot put in the vote 2023, question 26, and I can put in the vote 2024, question 27, and I've messed it up, so now I have to go back and retype 2 of the options because I got 2 of them wrong. Oh my goodness, that was an ordeal. Right, okay, there's several things we could talk about just to wrap up the stream here together. Let's go. So we'll do a vote. And there are options, they're voting in chat. There they go. For either 2023 long questions where I kind of like the solutions. What do we have? Very quick overview. If you're speedrunning 23, here we go. There's a technique here where you have, you sketch a graph and you square things and you work out P3 in terms of P1, great fun. And then you're shown this quartic equation with a degree x to the 4 in there. And hopefully you recognise that this has got something to do with P2. And then maybe the last one has got something to do with P3. The crucial idea is that x is not 0, so we can divide both sides by x squared, and that gives us something like this. At which point you notice that you have x and 1 over x, just like P1. You have to deal with x squared and x to the minus 2, but you've already worked out P2 in terms of P1, right? So you have this this relationship between the things. Okay, that's doing all right in the voting, so I'm going to keep talking about it for a second before we move on. The crucial thing you see here is like P2 means, if in doubt, always look back at the definitions. I'm always looking up and down when I'm looking at questions. I'm going to try and speed up with advice as well. Always looking up and down to see when it says P2, can I remember what that is? Where was the first P with a subscript? There it was. The definition says that this is x squared plus x to the minus 2 versus, on the other side, P1 squared, which means that something like this minus 2. So I should probably expand this out, right? And it's going to be fine. They tell me that it's equal, so I'm expecting this to work. If not, then I need to look back at the definition to check that I copied it out correctly and that I understood what n was. Is it 2? Is it 1? It's kind of both. That was confusing, sorry I said that. Okay, so down here, when I see x squared plus x minus 2, I realise that this is P2, but I have a rule for that. I know that it's P1 squared minus 2. So I'm left with this expression. And that's just a quadratic for P1. In the live stream earlier this year, I learned that some people call these hidden quadratics. So if you like, this is a hidden quadratic. Here's another one. And things are more complicated this time because the powers don't match up. You could divide this by x. What am I talking about? You could divide this by x. Well, what could you do? No, dividing it by x cubed is terrible. That's really rubbish. So maybe what I want to do instead is spot a root. Can I spot a solution? Can I find anything that works? If I can, then I can do some polynomial division. So I'm looking forward to finding a number that works. Maybe chat is telling me a number that works. Let's have a look in chat. How was the answer 3? Oh, I think I summed a geometric series. I didn't do it very well. I possibly got the wrong number, but then I moved on. 23.5 part 2. That was n minus 2. Okay. Am I going to run late? Maybe I'm going to run late. Quadratics in disguise. Asymmetry. So I think, yeah, there's some sort of anti-symmetry going on here, right? This thing is kind of the opposite of this, and the opposite of that, which maybe makes me realise that x equals 1 is a solution. There we go. X equals 1 works. So my task is something like pull out the factor of x minus 1 and then see what happens. And I think it's going to be good because I think, I should concentrate for this. No, never concentrate. I am hoping that I get something that looks like the previous part. I've sort of done some work now. I'm happy. I've found something that works. It says find all real solutions and there are 5 marks. So surely finding one solution should get me a mark, maybe. Who knows? But anyway, I'm smiling. So I found one, so minus plus 3. And I'm doing polynomial division, which I've done loads of times in the classroom. So hopefully this is all right. I don't think I'm doing a great job of it, but mostly because I am hurrying like nobody's business. 9x cubed minus 2? Yes, this is fine, right? And then 2x squared, but I wanted 5, so add another 3, and then minus 3x, so add another 1. And that does give me minus 1 in the end. And now I've got something which is very symmetric. It has the same sort of symmetric pattern that the previous one had, where things match up. I can see, for example, I should divide it by x cubed, and also I now see some x cubes. They made me work out P3, and I haven't used it yet. So, you know, maybe I'm off trying to do the question using other stuff from beyond the syllabus, but maybe I'm trying to pay attention to what did the question want me to do? Why did the question make me work out P3? I haven't used it at all to do part 4. So maybe I'll have to use it in part 5. And if you divide by x cubed, then you can recognise this as some combination of P3, P2, P1. You know how to substitute to turn those into P1 things. And then you have a cubic, which you will need to solve. But there we go. How do I do that so fast? This is my polynomial thing. Oh, you want to see chat. What's the vote? The vote is 2024, both questions. Okay. You want to see chat? Oh, sorry. Right, yeah, right. I see. That's me forgetting to stop the poll. There you go. Sorry. Although if you're here live, you could be in Slido seeing the question. Advice for multiplying out. In my head, I've got, so I knew I wanted x minus 1, and I write down x to the 6 because that will give me x to the 7. And then my plan is, I have the x to the 7 sorted, but disaster, I have created minus x to the 6. I'm not going to change this thing, I've written it down, it's there. So the only way I can fix that minus x to the 6, which I didn't really want, I wanted plus 2x to the 6. The only way I can get myself out of that pickle is to write down cleverly plus 3 times x to the 6. All I'm really thinking is, minus 1, minus 1. 2 taken by minus 1 is 3. And then that gives me 2x to the 6, but panic again because there was minus 3x to the 5. I kind of wanted some of those, but I wanted to subtract minus 5, so subtract another 2. And just keep going. It's like a chain of consequences. I wanted this x to the 6 at the start, so I'll just like keep working out what to write down next to fix whatever mess I've just made. And exam technique, I usually know that this is going all right if the numbers don't become too large. So if I get 9, part of me thinks that I might have got a minus sign wrong. And I know for sure that it's worked if I get to the end and the final numbers match up. I could maybe check my answer by multiplying out, but that's something where I know that I've got probably to a correct factorization. There is some advice about factorizing polynomials. Trigonometric identities, there are 3 of them printed in the syllabus. The syllabus is available on the MAT website. Good. Okay, and then the votes were not for the rest of these. Some stuff without differentiating. Look, the question tells you not to differentiate. Yeah. I'm glad we didn't vote for that question. Somebody made me do this question last year and then said, what was the point of this question? So you asked me to do it, so I'm pretty glad that we are not talking about the Fibonacci numbers either. Well, this is a good counting problem, and it's the Fibonacci numbers, so good fun. Everyone did that in 2023. We haven't voted for trees, but we have voted for 2024. Well, we've got a vector thing. No Discord for this. Okay. I talked about this question last year, but after the MAT, when people were, you know, they were done because they'd done the MAT. So let's try talking about it this year. I think I'm going to run a bit late. Yeah, I think I'm going to run late. I'm not going to try and do this in 8 minutes. That would be mad. But I am going to treat myself to a nice long blink, which I'll do just over here. Oh. If you've been looking at the screen for the last 2 hours, remember you are human. Remember to drink water. Remember to look away from screens occasionally. It's worse for me. I've got 2 monitors going and a sort of light over here. The light's really important because look, if I turn the light off, look how sinister I look. It's just really, it's really scary. So I've got so many lights in my face. Even the camera's got a little light, just a tiny one. Oh my goodness. Right, I'm back. Hello, welcome to MAT 2024 on the MAT Livestream. We're running into overtime. Here's some stuff you might notice when you read this question. We'll do the maths. But you might notice that this question involves vectors, which perhaps nobody was expecting for MAT last year, 2024, when we did the test through Pearson-VUE test centres, and we told everyone that they would be typing answers. The question opens with some description of how to type vectors. It says, in this question, we will write, and then there's a vector x, y, instead of the usual stacking it up notation. Because how on earth would you type that in a computer? Standard keyboard. And then you can multiply them. And this is a bit of a mess. There's reasons, you know, it doesn't look very nice, but we introduced a way for people to tell us about vectors. So I sort of hope this is reassuring. I think in the moment, people probably read this and thought, oh no, vectors. But it would obviously be a good thing we told people how to type vectors. I think we also designed this question so that it's a bit awkward with the less than or equal to signs. but a standard keyboard has a less than sign. So if people wanted to tell us about inequalities, I mean, they could type a very short sentence, P from 1 to 3 or something, if you care about those numbers. But you could also have a button on a standard keyboard for less than, if you want to. So there you go. Right. I'm afraid we're not going to have a Discord server. Sorry about that. That's me talking to a single person in chat who would like a Discord server, but sorry. Right. Okay. So here's the set of vectors, and there's it's a big set of vectors. I suppose it has to be a set, but whatever. A big set of vectors that lie on some sort of grid. P could be anything from 0 to 4. Q could be anything from 0 to 6. It says how many vectors are in here. And the idea is that you say exactly 35, and you get yourself a mark in a maths question, because hopefully that's straightforward. I think most people got this mark, and we're testing that you've understood that there are 5 things that P could be, 7 things that Q could be, and you pick any combination. So 5 times 7. Is that binomial curve combinations? No, not really. That's just independent choices. How big is a rectangle with 5 dots in one direction and 7 directions in the other? There's one in the thumbnail if you want to find a rectangle to look at. Okay. The question also has, and this is technology that we developed for the Pearson VUE experience, has lots of text that all appeared on the left-hand side of the screen. So the question parts appear on the right-hand side with a box to type an answer, but there's this sort of top text that traditionally in an older MAT paper, some of the ones that we've seen on this show, would be the text at the top of a question. But there's a bit of space there, which we use on this question to tell you what's going to happen in the question. So it says here, this question is about vectors, and whether or not such vectors can be written in this form, with A, B, and C, whole numbers each greater than or equal to 0. And then it tells you what's going to happen. We will consider, and then by considering, these are paragraphs to tell us what's going to happen. And that's there partly because we can keep the left screen showing information throughout the question, so that later on you don't have to switch between screens because it's just there on the left. So anything we put on the left can stay there for the whole question. And it looks a bit strange here where it's presented with all of the text at the top as if you do lots of reading. This is more a sort of reminder for people going through the question. Okay. Is there any way to contact you after the show? Oh my goodness, right, okay, hang on, what do they want to do? I think there's an email address in the YouTube description. If not, we're undergraduate.admissions@maths.ox.ac.uk. We're getting quite a lot of emails at the moment because it's the UCAS deadline yesterday, but if you email about MAT, then we will try and get to it. Yeah. That's emailing. Maybe me, but there's a team of people doing undergraduate admissions. Okay. There's an explanation part, which hopefully was not too bad, where you have xy with xy whole numbers. We can find whole numbers a and b, and a vector v in S. This kind of leftover small numbers for leftover bit. These small numbers for there, such that, well, your x component works out and your y component works out. And what we were looking for here was for people to tell us about the x component and y component separately. And there's maybe people in chat who are thinking about modular arithmetic, but we didn't expect anybody to say anything about modular arithmetic. So this is maybe a case where people thought that by saying modular arithmetic, they'd unlocked some sort of like bonus marks or something, but I'm just as happy with remainder, or you divide by 5 and then you have some leftover number that is not as large as 5. Might be 0 or might be 0, but these are all fine. Good, okay. Chat has gone really quiet. but maybe it's because I've gone very boring. We're just talking about a question now, aren't we? So there's a step down here, part 2. I know again it's A and B in here, labeling separate steps that you're supposed to do. In part 2 down here, you're looking at 2 different vectors like this, and now the vector 2, 1 has made an appearance. It wasn't there before, but now here it is. So prove that if these vectors have the same residue, then the difference is a multiple of 35. And this is, again, about thinking about how the x components behave and how the y components behave, I think. Oh, good, people are still here. So in this case, the x components are x plus 2k. Maybe I shouldn't say x component because the number x is a specific number, but you know what I mean. The first component. What am I talking about? No, I'm saying if these have the same residue. What am I talking about? What am I talking about? I'm hoping that. I guess I need lots of letters, but we know from the previous part that you can write any vector in this format. So in particular, I can write this vector. I can write this vector in this format. And I can do something similar for the other one. Yeah. So in particular, if they have the same residue, if it's this and the other one, which is plus m times m lots of 2, 1, is equal to, I guess these need to be different numbers over this side, 5, 0 plus d 0, 7 plus the same residue, which obviously when you're typing you can't underline it, but you can type something like the letter V, then we can take the difference, and if we take the difference, then the xy's cancel, the v cancels because it's the same, and we're left with k minus m, which is the thing I care about, vector 2, 1, and on the right we have, if I'm doing the difference, oh gosh, which way around am I doing the difference? I think I'm subtracting all of this. So a minus c, 5, 0, and b minus d, 0, 7. Okay, doing the difference. I should probably have switched to a blank bit of paper or something, right? Yeah. So you equate them, do lots of cancelling, or find the difference between these 2 expressions. And then on the one hand, we have, looking at the x component, twice k minus m is definitely a multiple of 5. And looking at the y component, literally k minus m is a multiple of 7. So there's a little bit of a step there to say, okay, this even number is a multiple of 5. That multiple of 5 is not coming from the factor of 2, it's coming from the other bit, it's coming from k minus m. There's a little bit of maybe trying to say something there to say, okay, the factor of 2, but come on, like k minus m is definitely a multiple of 5, and it's a multiple of 7, so it's a multiple of 35. And there's a follow-up part here to say, well, you just proved that if 2 things in this set, they've all got negative numbers on now, but 2 things in this set, if they've got the same residue, then, well, the difference between k and m is supposed to differ by 35. And in this case, I've got minus 0, minus 1 lot, minus 2 lots, minus 3 lots, minus 34 lots. None of those numbers differ by as much as 35. I think write down. If you think it's obvious, just write it down. Just go for it. I think probably it's a sign you're being careful if you think it's obvious. The question is quite structured, if that's what you've noticed. There's lots of steps in here which are related. There's an there is an A and a B in here, and it's about to be relevant. For example, 68 is twice 34, right? So there's some multiple of 34 times 2 and 1 or something. Everything fits together. Just something I like sometimes. I like it when the question's going somewhere. I'm trying to prove a thing. For me, this question is all about part 3, really. Part 4 is a nice follow-up, but part 3 says, what was the point of doing that? And the point of doing that is that you've got a list of vectors now, and you know they all have different residues, and you know there are 35 of them. So if you've got 35 different elements of the set S, well, one of them must be 0, 0, 0 in the set S, the origin. Because you know from part IA that there are exactly 35. You're kind of using every previous part, I think, to this third part of the question. And catch how IB worked. IB. So X component, you have 5A says something like X is 5A plus some sort of remainder, and you can choose the remainder to be 0 to 4. And the Y component says that you have 7B plus some remainder, and you can choose the remainder to be 0 to 6. And then you will get something for your pair of remainders will give you something that is in S. But just telling me about what the components are and telling me about remainders when you divide by 5 and 7 is probably enough, if you want to call them remainders. Right, okay. Part 3, really, the idea is that you've got all of these different vectors. So one of them is going to have residue 0. And then there's some algebra to say, as a result, I don't know which one of these it is, but I know that one of them has residue 0, because there are 35 possibilities, and here are 35 vectors. One of them has residue 0, 0, so for that one, I might as well call it xy minus k to 1. So for that one is equal to a 50 plus b 07. If you like, you can find the value of k, I don't know what it is, but you can find a value of k such that subtracting k from the y component and subtracting twice k from the x component gives you a multiple of 5 in the x component and a multiple of 7 in the y component. That's not obvious at all, but you can do it. Here's a set of 35 things. They've all got different residues, so one of them has got the residue 0, 0. And then rearranging this, just moving that onto the right-hand side, gives you the result. You need these things to be true, so that these numbers a and b are greater than or equal to 0. Or said differently, so that these vectors all have positive or 0 components. I'm planning to subtract 6834, as the most extreme thing that I'll subtract is 6834. Yeah, yeah, good. 5s and 7s. But it is supposed to just flow from the previous part. That you have these 35 vectors, and then one of them is the one that you want. The clue is the word hence. Hence always means using the previous part. So that's what we're doing there. Okay. A student claims something like this, something else. If x and y are whole numbers where the sum is at least 102, then x, y can be written in the form like this, where a and b and c are whole numbers each greater than or equal to 0, which sounds very complicated, but in fact is just false. And once you understand what they're claiming, you can spot that they're claiming something enormous. They're claiming that loads of things can be written in this form, including some quite extreme things. So once you've understood what the student is claiming in that last part, right at the bottom of the question there, once you've understood that, then it shouldn't be too hard to find a counterexample. Yeah. Good. Right. my example is very near one of the axes. I think it's easier to work with over there. So the student claims something about numbers with x greater than 0, y greater than 0, and x plus y really large, but I could still have one of them being quite small. And small numbers like if y is 2, if x is 1, then I'm in real trouble, because I definitely don't want any of this c times 2, 1 stuff. I'll zoom in a bit. If x is 1, then I definitely don't want any of this c 2, 1 stuff. That's too big. C would have to be 0, and also a would have to be 0, and then b is not looking very good because I didn't say 0 for my x component. So you can kind of rule out things like 1, 100, 101's fine. 1, 101. Oh, do I have that nice graph from last year? I'm not sure I do. Let's see if I can find it. Did I decimal it? Oh, you watched the stream from last year. Oh my goodness. 2024, question 26, yeah. Does Desmos do this? Okay, the trick here is going to be getting Desmos to make this look nice. There's a chart here of all of the things that you can make using, in this case for this picture, this is vectors made by taking a times 50 plus b times 07 plus c times 21, where those a, b and c are positive or 0 and at most 35 for no particular reason. Or is it at most 50? I don't know, maybe it's most 15 or something funny. But you get this kind of region where there are some numbers that you definitely can't make. Around here, around the axes, it's quite hard to make something. There's big gaps between these points that you can make. But as you move up and to the right, in some sense, you get to this kind of large patch where you can make everything. And what you've proved is that starting from, where is it? Is it 68,34 around here somewhere? Starting from 68,34 around here somewhere, you can make eventually everything above and to the right of that. I think I need more vectors. There we go. So if I fill this in, then you get this kind of grid over here where using lots of these vectors you can piece things together. That's my chart from last year. Good. Can I explain why 0 factorial is 1? I have a short answer, which is that most people define it to be 1. But a bit like how I define 1 plus 0 to be 1. But that's not a great answer. My philosophical answer, I suppose, is that there is exactly one way to arrange no things, which is to not do it. Which is to have no things in a row. I think that's one solution. Yeah. Somebody's just seen the Instagram reel. Oh, that's just gone on Instagram. They filmed a whole first lecture on the lecture capture video, which is not amazing. It's good enough if you missed the lecture and you want to catch what happened. It's good enough, but it's not YouTube quality. And they separately had the social media team in the room filming quite a nice reel of everybody arriving for the lecture. So I'm on social media again, he says during a YouTube live stream. Right, ant face cube thing. Can't remember if I told people last year, but you have been saved from a much harder version of this question. When we were drafting versions of this question, there was a version where the ants occasionally lied, maybe lying depending on what they could see. And those versions of the questions were absolutely awful. It was a little bit of a truth and lie kind of question, and that survives in the question where it says the ants will always answer truthfully. We decided to fix this as being there's answer always truthful. Okay, so there are some counting arguments here. There is a lot of even and odd stuff going on in the first part. The second part's maybe my favourite because the answer is just yes. It feels like maybe it should be impossible, but there's a way to colour the faces such that each ant really can see 2 red faces, you can do something like this to colour that bottom face and colour the top face. What have I done? What have I done? That's not exactly 2, is it? That's exactly 1. What am I talking about? Have I forgotten how to do this question? All 8 of the ants can see exactly 2 red faces. I have forgotten how to do this question. Oh, the other way round. The other way round. The other way round. You colour the other faces red. Oh, this is going to be bad because I'm just colouring in the entire picture. I'll just do it like that. There we go. Right, colour in everything else red. Whoops. There we go. Okay, maybe I should wrap up because I'm just making silly mistakes now. There's an information part of this. Exactly 5 of the answers to say yes and exactly 3 to say no. There's some case checking you could do to say between them 5 ants can see quite a lot of the faces. So you can think about which faces overall they can see. There's something like you can pair up the ants. I can't remember if this is a good thing to do, but something you might consider is that you can pair up opposite ants, and then that pair of ants can, between them, see precisely all of the faces. It's quite good. So I guess for the first part, there's an argument there to say if the total number is odd, then in each pair of ants like that, one will see an even number of faces and the other will see an odd number of red faces. Even number of red faces, odd number of red faces, because it has to add up to the total. So you'll have 4 of them overall, and if the total is even, then in these cases either neither or both will see an odd number, depending on where they are. There you go. Right, and I think I'm wrapping up. The last part was the hardest because such a shape does exist. It doesn't have to be a cube, and there's an argument where you, well, my favourite argument for the last part, where, and it stands alone, I think. You don't need the previous setup. A 3-dimensional shape is constructed such that each face is either a square or a hexagon, with 2 faces meeting at each edge and 3 faces meeting at each corner. Each face of the shape is placed either red or blue. Consider the edges, where a red face meets a blue face. I think what you can do is you can place a beetle on each edge. You have these kind of edges of this shape. I don't know where the shape goes, maybe it involves some hexagons, but you can place a little beetle on each edge, and you can ask the beetles what they see. And some of your beetles can see 2 red faces, and some of them can see 1. So this one says 2. This one says 1 because it can see that one. Let's finish colouring it in. And there's maybe a beetle around the corner somewhere. 1, 2, 3, 4, 5, 6 hexagon. There's maybe a beetle around the corner somewhere, which can't see any, and it says 0. Speech bubble. And we're interested in the number in the middle, but you can count the edges in a couple of different ways. One of them is to think about the total of what all the beetles say, and the other is to think about the fact that these are squares or hexagons. They've got even numbers of sides, and that gives you some equation about how many sides of how many red sides of shapes there are. You can also do something where if you paint a blue face, then 4 must be able to see that face. There we go. Right, MAT Livestream, always the best art stream. There you go. We're going to finish on that note, I think. Some beetles just having a chat. There's a way to convert that into an equation. In particular, it's these beetles in the middle I care about. Should I try and write it down? So maybe the number of them, the number of such beetles is maybe A, B, and C for each of them. And then, well, what they're counting really overall, if you work out 2a plus b plus c, what they're really counting in that case is you have some squares, and standing around each square there are 4 little beetles who are counting its sides, and you have some hexagons, and standing around each hexagon, if it's red, that'll up the count for those 6 beetles standing around the sides. And that's it. What do I mean? 0 times c. 0 times c, because sorry, but they can't see any of these red edges. Sorry, 2 times a plus 1 times b. Crucially, don't just add them. Whoops. We're finishing on a bit of an error, but there we are. 1 times b, 0 times c, 2 times a adds up both counts. Red. I'm going to say sides of shapes. Not the edges precisely, because an edge is made of 2 sides of shapes coming together. Both count the red sides of shapes, and almost everything in this equation is even, except for b, and that's the thing we care about in the question. Last minute tips then, as we wrap up. Remember, you're good at maths. Maybe you're also good at drawing. I know I'm not. But remember that the questions are supposed to be hard. I think we've had a lot today about going back and looking back at the question and working out whether things are as bad as they seemed. Because often you have like a student making some outlandish claim that's just wrong, or you have an equation which is like degree 7, which looks impossible, but you can find a solution and then kind of crowbar your way in that way. We had a function where everything was actually quite constant and flat in between. Sorry for all the zooming, it's really nauseating, isn't it? Often it's the case that going back to the setup and messing around with it a little bit, just experimenting a bit, which is maybe a stressful thing to do during an exam with a timer, but it's also maybe how you have ideas, and part of this is ideas. So yeah, good luck everyone. How can a beetle see 0 sides? I mean, it's 0 red sides. It sees 2 blue sides for what it's looking at. Sorry, just counting red in that question. You're going to be typing, so no diagrams, yeah, you're also not expected to draw any diagrams. I just did some lovely diagrams. In 2024, no one could submit their diagrams, so they have to do something a bit like more like the stuff I'm saying out loud and not the stuff I'm drawing. The drawing is how I understand what I'm doing. I would also have to write up, I think I would have to write more words than this. I would have to say what these letters are with just a little sentence to say what I'm doing and a little sentence to say what my beetles are up to, but something like that. Right, okay, yeah, thanks to people in chat. Thank you for coming along. I'm going to put the you've got this in, you've got this, smiley face. Remember, either during the test or afterwards, that you actually do like maths as well. Often doing a big high stakes exam can be pretty exhausting. Try and remember, maybe not during the exam or immediately afterwards, but try and get back to all of that maths that you put in your personal statement, all of that stuff that you're looking forward to doing at university, the other half of maths that you've learned in school that isn't on my little syllabus for this maths submissions test. I think you've got this. Okay, right, good. We're wrapping up, I think. Thank you, chat. Can't do it without you. It's been a pleasure to teach you about AS level maths and really tricky questions you can do with that. Either way, whether you're applying to Oxford or not, that you've seen something new. We will be back at some point in the future. I've forgotten my schedule. I'm bluffing for time to try and remember my schedule. I think I've got a couple of weeks out. I think we're back in about 3 weeks. I should go and look it up, shouldn't I? Oh, what do my plans say I'm doing? 13th of November. That sounds like it could be 3 weeks, maybe 4. Could be 4 weeks. So I need to load up a calendar. 28, take 3. Yep, 4 weeks. Yep, we're back for some debrief stuff. Good. Okay, take care, everyone. Look after each other. Maybe see you in a bonus episode in about 4 weeks' time. But that's been the pre-MAT live stream. Have a nice evening, have a nice weekend, and all the best with the mat. Bye.